second. Just wanted you to have that in there. Okay, so the very last problem we did yesterday was we found that margin of error using the formula, and then we created a confidence interval. This is the formal definition of a confidence interval, and they're calling it a C confidence interval because C is the confidence level that we are using to find that Z value, that critical value. All right, so what we're going to do is, this is what it's going to look like if we are estimating our population mean. Essentially, this is the calculation that we're doing, though. We're taking our X bar, which is our sample mean. We're adding and subtracting that error to it, and then that gives us this range of numbers. And we graphed it yesterday, if you remember, on a number line. In that range of numbers, we then say we are 95 or 90% confident, or there's a 90% probability that our population mean is within those numbers. So the whole goal of this is to estimate that population mean. Populations, remember, are very large groups of numbers a lot of times, so it's difficult to find the actual value. So things like confidence intervals are what we use to estimate it the best we can. Okay, and remember, the bigger your N is, the better. So we're going to start with this problem. It says use the confidence interval to find the margin of error and the sample mean. So this is the opposite of the problem that we did yesterday to end the lesson. So yesterday we found the sample mean from the data, we found the margin of error, and then we added and subtracted it on to the sample mean to get these values that were the end of our interval. So here we're working backwards now. You have the interval. You can almost make a little picture of it in a number line if you want to. You've got 1.71 on the bottom, and you've got 2.05 on the top. Okay. As far as where the mean or X bar is located, it's just going to be the middle or your midpoint of those two values. So we don't really need a formula for that. We're just adding them up and dividing by 2. So you can do that real quick. 1.71 plus 2.05 divide by 2. And that's going to give me my X bar is equal to 1.88 in this example. The other thing that we need to find is the margin of error. And remember, the margin of error is what we added and subtracted on to that sample mean to get the ends of the interval. So E, the margin of error, actually shows up twice in this picture, in this interval. So there's a couple different ways you can calculate it. You can find the difference between the lower end of the interval and X bar, so the difference between 1.71 and 1.88, or you could do the other side, 1.88 and 2.05, whichever one you do, it's going to give you the same answer. So I'm going to do 1.88 minus 1.71, and I'm going to get my margin of error is a 0.17 for that. Okay. All right, you guys try the second one real quick. Find the sample mean and the margin of error. Correct answers. You should have an X bar of 25.88, just the midpoint of your interval, and then the difference between that and either end of your interval is going to give you 4.27. Okay. Any questions on that? Okay. All right, so yesterday in your notes, the last problem that we did was the one with the data that you guys just put in your calculator a second ago. There were 40 student athletes, and it was the number of hours that they work out each week. And we found a confidence interval for that. Yesterday, we actually found a 95% confidence interval if you look back in your notes. You can use your graphing calculator to find a confidence interval. So this is more so a check than anything, because remember, you won't have your graphing calculator on a test, but you can use it if you want to check your homework or when you work on your future project, your last project that's coming up. All right, so in order to find a confidence interval, we're going to do the following. Once you have your data in L1, which you guys all have that already, you're going to go into stat. Okay, and then normally we calculate things. We're going to start doing more testing for statistics. So we're going to go all the way over to where it says tests. And then we're going to choose number 7, which is a Z interval. Okay. Z interval because we're using our Z critical values for a test like this. When we do section 6.2, we'll do another type of interval, a T interval. So you'll have to know which one to choose from. Okay, input. So you have two ways that you can put this in. We put our data already in L1, so we're going to use that data. So we're going to use that selection. If you had statistics, like if you had X bar, if you had the variance, if you had some other things, you could do it with just that. You wouldn't need the data instead, okay? But we're going to use data for this one. Yesterday, they told us that the population standard deviation was 2.3, so go ahead and put that in. That was given information. List, we put our data in L1. I think that's already in your calculator. Does anybody not have an L1 in that spot? That should be the default. Okay, frequency should just be 1. We're telling the calculator use each number once that we've put in. Okay, and then you can choose the confidence level. This example, yesterday we did 95%. We want a 99% confidence level. So you're going to change your C level to 0.99, and then it'll calculate it for you. Just hit enter a couple times. Okay, so at the top, it's telling you the confidence interval that you would find, that number line shaded area. It's a little bit bigger than the one from yesterday if you compare them. It tells us the sample mean, which is what we calculated yesterday, so you can check that. It also tells us the sample standard deviation. That 2.3 that we plugged in was the population standard deviation. We have the sample standard deviation, and then it tells us the N is 40, so it's a good check that we got all our numbers in there, so we knew that. Okay? So any questions there using the calculator to find a Z confidence interval? No? Okay. So like I said, you can use this to check things as you're going through your homework. All right, we're going to do another one of these together to practice now, putting it all together, all the pieces. So we have a random sample of 36 business days from February 24th, 2016 through February 24th, 2017. The mean closing price of Apple stock was 116.16, and assume the population standard deviation is 1027. We want to construct an 85% confidence interval for the population mean closing price. Okay, so let's pull out all of our important information here. Number one, I want to always check either A, is my population normally distributed, or B, is my sample size bigger than 30? Bigger than 30. Okay, so my N here is 36. Okay. We have the population standard deviation, which remember is what you need to do this type of confidence interval. All of the ones that you guys are going to do in this section 6.1, you'll be given that. Here, the mean closing price is just of those 36 business days. It's not every day of the year. So that's a sample mean that you're given, an X bar, 116, 16. And we also want a confidence interval of 85%. So that's my C value, 0.85. Okay, once you have your C value, you can hunt for your critical Z value that's associated with it. So remember, you have some ones that are commonly used on your chart under critical values, level of confidence. Is 85% one of those? It is not. Okay, so we have to figure it out. All right, so how we figured out the Z value yesterday, we did this with a 70% confidence interval yesterday. So 85% of the data is in the middle of our normal curve, which means what percent is in total in the tails? So 15 total, and then if I divide it by 2, which is the next step, we can say that each tail has 7.5% in it. And that's the number that you're going to look for in the middle of your chart. You're going to look for a cumulative area of 7.5%, which is 0.075. So that's what you're hunting for, and you want to find the Z value that goes with it. We're looking for the one that's on the left, so you're looking on the negative values in your Z chart. Find the closest one to 0.075 on there. And I've got a 0.0749, so that looks pretty good. Negative 1.44. So the critical values of Z are plus and minus 1.44. They're always one positive and one negative. The positive one, though, is what we're always going to plug into the margin of error formula because it's always going to be a positive value that we get out. Okay, so this one just has an extra step there because you have to find that z value versus it just being a common value. Okay, once you have your value for z, you can calculate your margin of error. Margin of error is your critical value of z times the population standard deviation divided by the square root of n. So positive 1.44 times standard deviation 10.27 over the square root of 36. Type the whole thing in your calculator. Let's give it 2 decimal places because everything's dollars and cents here. So times 10.27 divided by square root of 36, or 6. I'm going to get 2.46 is our margin of error. Okay. Once I have that, to get my confidence interval, I'm going to add and subtract that margin of error onto my sample mean. So 116.16 plus and minus 2.46. If I subtract, I get the bottom end of the interval. If I add, I get the top end of the interval. So 116.16 plus 2 point, or minus, do minus first, 2.46. 113.7, I'm going to say 70, again, because it's dollars and cents there. 116.16 plus 2.46, 118.62. Okay. They are often going to ask you to interpret this as well, what that means. So the interpretation is, remember, we are always estimating the population mean. That's the whole goal of this. So the interpretation is the population mean is between 113.70 and 118.62 for the stock closing price is what that represents, with 85% confidence, or you could say there's an 85% probability that the population mean is between those two values for the closing price over that period of time. Right. Any questions on any piece of that? All right, you guys are going to try this one. I'd like you to work with a group on this one, maybe group 2, 3, 4, I'll let you decide. So find some friends, and then you guys are going to put pieces of the answer up on the board for me in a few minutes. So get together, go, and then we'll put it up and check it.
Could you go back to the last slide?
Yes, I can. I froze it.
Thank you.
Awesome, perfect. Okay, I just got one more problem for you, and that's it. Let me erase this. Okay, so one thing we can do with that margin of error formula, this guy that you already have, is we can solve for n in the equation. So if you get n alone, you divide by, well, you have to multiply by n, I guess, on both sides first, so I don't want to go through the whole thing, but you multiply this by the square root of n, and then you divide by your z and your, no, you divide by e. Let me just write it out. It's too much for me to talk through. All right, if I have this formula and I want to solve for square root of n, I multiply by the square root of n. So it looks like that. And then I just divide by e on both sides. There we go. Got it out of the denominator. Got it alone. And then you square both sides. And when you square both sides, you end up with what you see over there on the left. Now, why we would want to use this? Let's say we want to have a certain margin of error. Maybe we want our margin of error to be within 5 units of whatever we're measuring, or within 3 units of whatever we're measuring. There's a certain sample size that will make that happen. So we can use this formula to figure out how big does our sample size need to be? So how many people do we need to survey to be able to have a small enough margin of error for what we're looking for in our test? Okay, so when you use this formula, it's important to note that you always round up. Whatever you solve for, you're going to, in most cases, get a decimal. You round up. Even if it's 10.0001, you're going to round up to 11 because it's a minimum that we're looking for. And if we round down, we don't have enough. So an example here, we want to determine the minimum sample size required if you want to be 99% confident that a sample mean is within 2 units of the population. So that's a little kind of thing that you kind of have to hunt for there. They don't explicitly say that that is your margin of error, is that 2 units. So they're telling you that E is 2. They're telling you that you are 99% confident. So that's your C. And they also, in this problem, tell you your population standard deviation is 1.4. 0.99 is one of the common levels of confidence that we use, so you can find it on your chart. Your critical values for Z there are going to be plus and minus 2.575. Yep. Okay. And then that's all you need to be able to then use this formula. So if I want to solve for N, the sample size needed to have that margin of error with that level of confidence is my critical value Z. Again, we're going to only use the positive one, times my standard deviation 1.4, divided by my E is 2, and then don't forget to square it at the end. And then whatever we get, we're going to round up. Square that. I get 3.249. So I'm going to round it up to 4. So as long as we're normally distributed, we only need a sample size of 4 to be able to be that confident with that margin of error. But remember, 99% confidence level, that's a really, really big interval. So if we wanted a smaller interval, like a 95% or a 90 or an 80, likely we would need a bigger sample size because we want to be more confident with that smaller sample size that we have. Okay. All right. Any questions? All right, that's it for 6-1. All right, so you guys have the rest of the period today to work a little bit, and then tomorrow, half hour. So between those 2 times, you should for sure be able to finish your 6-1 Math Excel. It's technically not due until Thursday, but I think you can get done in class. Okay, and then Thursday and Friday, we're going to do section 6-2, and then next week you will have a quiz on Monday. Is it a Monday quiz? Monday quiz, open note, just over these 2 sections on confidence intervals. Okay. All right, I'll do cell phone lotto, and the rest of the period is